I'm going to talk a little bit about what a sampling distribution is. A sampling distribution is another way for us to estimate the parameter, just like when we use the confidence intervals. So in order to be able to construct the sampling distribution, just like with the confidence intervals, one of the really important things we had to have was being able to understand sampling variability. And just as a reminder, we're able to understand sampling variability when we have a simple random sample. Now, by definition, what's given in the video is a sampling distribution, right here, is a graph of statistics, or a plot of the different statistics. Now, what do I mean by a plot of statistics? Can we just plot a bunch of statistics that don't measure the same thing, that don't come from the same population? No. These need to be different statistics that all come from the same population and are measuring the same thing. So, for example, in the sampling distribution worksheet you had, what your population was is we were looking at flips of a coin. And the idea behind this exercise was to take multiple samples, from each sample calculate a statistic, and then to plot the different statistics that you got. So let's just say, for example, that the first time you flipped the coin 20 times and you found out that 55% of those coin flips were heads. What the graphing program would have done for you is it came over on the graph, and let's say that this line right here was 50. What it basically did was just put a little mark next to 55. And then let's say you flip the coin another 20 times and your next statistic that you got was 40% of those were heads. So then there would be a plot here. And eventually what happens is you guys did this all the way down to 30 tries. Let's say my last one I got was 60%. What would have happened is all 30 of these tries would have been plotted on your graph. And I realize this is a crude representation, but you'll get the idea. And what would have happened after all 30 of these were plotted is you should have seen that your overall graph, if done correctly, should have been a bell shape. And it would peak right above the 50. Now, in the case of a coin toss, we all know if you could flip a coin an infinite number of times, the expected percentage of the time that you would see a head would be about 50%, and that would be the parameter in this case. This is one of those few times that we know what the parameter really is. And so what you should have seen when you plotted all those statistics is, even though they were all different, when you plotted them all together, that plot would peak above 50%, or somewhere right around there, because that's where the true parameter is. And another thing to notice, or I guess not notice, but I should point out, is the more samples you take, the clearer this curve is. So instead of having you repeat the exercise 30 times, had we had you do it 1,000, this bell shape would have been very distinct, and you would have very easily been able to see that it peaked right at the 50%. So the important thing to know for a sampling distribution, that's all it is. It's a plot of the statistics, and when we plot all of those statistics, we should get a very nice bell shape, and at the top, this is where the parameter is always going to be. So, for example, if I gave you a sampling distribution and it looks something like this, and then I marked 30% down here, and I asked you what would be the best guess of the parameter, you could automatically say right here, 30%. So far in the course we've talked about two different ways that we can estimate parameters. One, we can use a confidence interval to get an idea of where the parameter is, or two, we can use the sampling distribution to look at the plot to get an idea of where the parameter is. And one thing to notice, with a confidence interval, it's just that, we just get an interval. But with a sampling distribution, and let me scroll back up here, we actually get a pretty good idea of where the exact number for that parameter is. So the question is, why not use the sampling distribution? Well, in practice, we don't generally use the sampling distribution, and the reason for that is sometimes we have to take thousands upon thousands of samples to really get a clear idea of the sampling distribution. And it's just too expensive, too time-consuming. There's a lot of reasons why we don't take all those samples to get the sampling distribution. So in practice, we generally use the confidence interval because we can just make one of these, and just like we talked about earlier, we have a clear understanding conceptually about what that confidence interval really means, and usually just having an interval suffices. And this is not used because it's impractical. So the important thing just to take away from a sampling distribution is that it is a plot of all the different statistics. It's usually bell-shaped, and it peaks where the parameter is. So if you can remember those two things, the bell shape and that the plot peaks where the parameter is, doing really good. So if you have any other questions on sampling distributions, just let me know.